Welcome to video number 2, interval notation and domain and range. Here are the objectives for this lesson. We're going to go over some vocabulary, set notation, interval notation. We're going to review domain and range. We're going to write domain and ranges, and we're going to find domain and ranges from a graph, a set, or a relation in a table. Here's some vocabulary. A relation is a set of ordered pairs. An ordered pair, remember, has an x and a y coordinate, a first coordinate, and a second coordinate, and that's a set of ordered pairs. But a relation is not necessarily a function, because a function is a relation where each element of the domain is paired with exactly one element in the range. And we'll talk more about this in a little bit, especially the tests that you use for that. An independent variable is the x-coordinate or the members of the domain. So your x-coordinate is going to be the independent variable, and the y is going to be the dependent, and y is going to depend on what e is. So if you ever are independent, x is. So if you think of it like this way, the x is input, and then the output is the dependent variable. So it depends on what's on there. The domain, of course, is going to be the set of all values that make it true. And then the range will be the set of all values for y. All right, let's talk about interval and set notation. And these are some examples from a worksheet that you're going to see when you get to class. But I want you to notice some things here. Here's written as an inequality. It says x is greater than or equal to -3, but less than 5. Written in interval notation, it looks like this. Because there's an equal sign, this is a bracket. Because there is no equal sign, it's a parenthesis. Okay, and so these two things mean the same thing. If I were drawing this on a graph, you would see that at -3 I had a closed circle because it was equal. And at 5 I would have an open circle because it is not equal. It's just less than. And then you would shade in between, so it's between. So on this one, for instance, I have x is greater than 2. So what this means is it starts at 2 and then goes to infinity. And you can see what that looks like on a graph. You can see that you have an open circle at 2 and then going with an arrow. Notice this one doesn't have an arrow, but this goes to infinity to the right. And you always go from smaller to larger. So for instance, on this one, x is less than or equal to 3. What this looks like, and I'm going to go ahead and draw the graph on here. Here's 3, and you don't have to draw all those in there. It's equal, so it's closed, and then it says less than, okay, with a big old arrow, right? So on this side down here, this would be from infinity, and since infinity never ends, it doesn't get a bracket, it just gets a parenthesis, and that goes from, negative infinity to 3. And does it include 3? It does. So I have a bracket just like this. If I wanted to do all reals, right, then it would go from negative infinity to positive infinity. And then what it would look like on here is just everything. So that's a real quick introduction. When you want to find the domain from a set of ordered pairs, we're going to do this from different places. We're going to write this in a different form. So for instance, the domain of this function is the set of all x values. So I have 2, 1.34, negative 2.34, and 4. And that's set notation, because the relation notation there, the relation is written in set notation. And then the range are just going to be all the second values, the y values, so 4, 5, negative 4.1, and negative 5.88. And so you get the curly brackets. Now, if you're going to write the domain and range from a graph, and part of this came off, but we can look at just the domain and the range of this graph right here. The domain is going to be all the possible x values. So I'm going to look all the way out here, right? And then I'm going to look all the way here, and I'm going to see, is there a graph? Is there a y value for each one of these x values? And as you can see, this is all reals. The domain is going to be all reals for this one. So to write all reals, I would go from negative infinity to infinity. Now the range, which somehow that got cut off, the range for this graph is from, you're going to look on the y-axis. So I'm looking down here, and I see that it may be leveling off, but I don't know for sure. But because this is an arrow, I'm going to say that it's still probably going a little higher, right? And so this, in this case, it's going to go from negative infinity to infinity as the range. So it's all reals also. You know, if you had a line, all lines that go like this, the domain and range are both going to be, yeah, all reals. All right. Domain and range from a table, I would probably use set notation. So the domain is going to be all the set of the x values, that's the domain, and then all the set of the y values is going to be the range. So if we're looking at these graphs once again, and then these graphs are functions, and the reason I know that is because they pass the vertical line test. So in other words, to be a function, for every x value there can be only one y value. So if I do, just drawing real quick, a vertical line, you can see that it crosses the graph in one point, no matter where I put that line. So in that case, this is a function. And so is this one over on the side. This one over here is also a function. All right, so the domain on this one, if I look at it from side to side here, I can see that because these are arrows on the edges here, that the domain is all reals. So I'm going to write from negative infinity to infinity. Okay, and then the range of this function is, I'm starting here in these negative values, and there are no values below 4 or negative 4. So starting at negative 4 and going to infinity is going to be my range. So negative 4 to infinity. All right, likewise on this other one, the domain is going to be all reals. Same thing. It's got the arrows both directions, and it's going to keep going in both directions forever. The range, however, starts out at negative infinity and goes all the way, see this downward, so negative infinity all the way to positive 3. And it includes positive 3, so it goes to that. In fact, I need to change that to a bracket because it includes negative 4. Okay, these are numbered 6, 7, 8, 9, 10, 11. And I'd like to look at, first of all, I want to determine whether these are functions, right? So if I apply the vertical line test to, say, number 6, you can see that a circle is not a function. So this is not. This particular one right here, which looks, the number 7, it looks like it's kind of a logarithmic or exponential, probably logarithmic. Anyway, it is a function. The next one is a line. It's also a function. This is, I don't even know what number 9 is. This is not. Number 10 is quadratic, and it is a function. And this last one is the absolute value graph. It looks like a V. It's a piecewise function, and it is a function. Okay. So what I would like for you to do is try your hand at writing the domain and range. for all 6 of these functions, and put that in your composition notebook. You can do a little sketch of it. It doesn't have to be graphed, like draw a circle and then write the domain. You'll have to count on there. It's kind of hard to see, but try. And then we'll talk about these when we get to class. Okay? See you then.